In this video, we want to explore continuous statement in SCL language within TIA Portal. Continue is a part of loop instructions that abort the execution of a loop in SCL programming language. Here is the diagram related to continue in a for loop structure. We have a for loop, a condition to check. We have some statements to perform, and here we recheck the control tag, and in a certain condition we abort the execution of a for loop. To understand this language segment of SCL language segment, we will create a simple vector, an array into a portal, and we will fill the array with the loop counter from 1 to 10. Then by using continue statement, we will partially fill, and we will examine the functionality of the continue statement. So first we should go create the vector, fill it with 1 to 10 with the loop counter, and return to the second example, that is the simple demonstration of continue instruction. For the first example, we need to create one dimensional vector. It's an array by 10 elements in DB2. The name of DB2 is assigned to vector, and the name of elements are considered data. Our SCL program is developed in OB1, and I used for loops. If you are not familiar with for loop into a portal, please watch the related video about the for loop, and you will gain the basic functionality of for loop in SCL into a portal platform. I will explain this code section. It's very simple and very helpful to understand the program structure. First, I initialize the loop counters that are temp variables in OB1. Then I created a restart strategy to initialize vector elements to 0 by using a binary signal. This binary signal is defined in tag table, PLC tags. It's M200.0. It's a memory from PLC memories. So when the signal is true, we reset all cell elements to 0. And otherwise, when the initialization phase is finished, we perform filling here. Each cell is assigned with the loop counter at that iteration. Now we download the program to the CPU, and we will function test the basic functionality of the program. At the first step, we enable the restart command, and all vector elements should be false, as we see here. The next step is to release the reset command. We turned off the reset command, and filling process is done. As you see, the first cell is filled with 1, the second is filled with 2, the third is filled with 3, and eventually the last one is filled with 10. It's very similar, it's identical to the vector that we designed here. The next step is to abort filling the vector. Abort filling the vector by using continue instruction. We want to exit filling at this level and restart the filling instruction from the beginning. Let's perform this instruction. Let me type this program section in TIA Portal, and let's see what's happening. Copy this section, paste it in. We don't want to use it in initialization because we want to be sure that all elements are initialized to 0. But this is the filling instruction. In filling instruction, inside the for loop, you decide what's your policy to abort. In this case, we fill all elements till cell number 7. We fill number 7, and after 7 we abort loop execution, and we restart the loop execution from the beginning. So let's save and download the program to the CPU and check the first initialize. All elements should be 0 here, and then remove the restart command, and we see that the elements from cell number 8, 9 and 10 are 0. They are not filled because loop is aborted from this section. By using this continue instruction here, the for loop is not executed for I equal to 8, I equal to 9 and I equal to 10, and it exit from here and restart from the beginning. Contrary to the previous example, we want to, in the third example, we want to skip a region inside the vector. We want to skip filling cell number 5, 6, 7 and 8, and again filling cell number 9 and 10. This is the most important and most distinctive difference between continue and exit. This is only possible to do it with continue. We will see it in example 4 that it's not possible by calling exit in SCL. So we copy the code section here and insert it in the for loop. We change the conditions here, and we want to skip a region inside the vector. Let's see the vector. Vector is initialized because of the command signal. We turn the command signal off and check the vector in online mode, and it's like it's similar to the case that we expected here. We failed until the cell number 4, and we skip cell number 5, 6, 7, 8, and we failed again from 9 to 10. Here's the same behavior here. Cell number 5 is a skip, 6 is a skip, 7 is a skip, 8 is a skip, but cell number 9 and 10 is failed. The last example is the main difference between continue and exit. In continue, you can skip some cells and the entire for loop is not aborted. You can skip a region inside the entire vector. You can fill the first part, you can skip the middle part, and you can fill the final part. By using continue, it's possible, but by using exit, your for loop is not when the condition is met, the for loop is exited, and the rest of the region is now filled by the cell number. And this is the difference in case of if you want the behavior like this, want to reset an area between two field area, using continue is wise, but if you want to exit the entire loop, you should use exit instruction. To test, we just need to change the instruction from continue to exit here. Exit. And if we download, we see that the we need to restart. We need to restart, and we need to turn off the command and check the vector. Loop is exited from here, and the rest of the rest of vector is filled by 0.